Right, well, let's just do a whole bunch of examples. So all of these are going to be differentiating polynomials. So we've got f of x equals 3x to the power of 4. I think I've used this one myself. So f dash of x, when we differentiate it, it's going to be 4 times 3, which is 12x, and then the 4 loses 1, it becomes a 3. Easy enough. These are not going to be really all that difficult. Y equals 7x to the power of 5 minus 2x to the power of 3. Find dy dx, which is, we differentiate y with respect to x. So 5 times 7 is 35 x, and then the 5 loses 1 to the power of 4. Minus 3 times minus 2 is minus 6. The x stays there, and the 3 loses 1, and that's it. We just exit it. That's the end of that one. Differentiate f of x is 4x to the power of 6 plus 5x, so therefore f dash of x is going to be 4 times 6, which is 24. X, the 6 loses 1, it becomes 5. There is a 1 here. 1 times 5 is 5, and the x disappears. It becomes x to the power of 0, which is 1. If y equals half x to the power of 7 minus 3x squared, find dy by dx. So dy by dx. So for this one here, 7 times a half is going to be 3.5. The x stays there, and we lose 1 from the 7. And here, 2 times negative 3 is negative 6. X, and it becomes a 1, but we don't need to put the 1. We can just leave it like that. Differentiate this one, 6x to the power of 5 minus 10x cubed plus 8. Well, dy dx, or f dash of x, 5 times 6 is 30. X, the 5 loses 1, becomes a 4. 3 times negative 10 is negative 30. X stays there, the 3 loses 1, becomes a 2, and the constants, of course, annihilate, they become 0. Find dy dx if y equals 3 over 4 x to the power of 8 minus x to the power of 4 plus 12x. All right, so dy by dx is therefore going to be equal to 8 times 3/4, so 24 over 4, x to the power of 7, the 8 loses 1, minus 4x to the power of 3, there's a 1 in front of that x, remember, plus 12, and we can rewrite this. 24 divided by 4 is, of course, 6x to the power of 7 minus 4x cubed plus 12, and we're done with that one. F of x is brackets 2x cubed minus x squared plus 5. What do the brackets mean? Absolutely nothing. It's just there to distract you. So therefore f dash of x is going to be 3 times 2, which is 6. X, and then 3 loses 1, becomes a 2. 2 times negative 1, and there's a 1 there, is going to be negative 2 x to the power of 1, and the 5 will disappear, and that's our final answer. And differentiate and simplify the following. So 5x to the power of 4 minus 20x squared plus 15. So therefore f dash of x, we differentiate it. 4 times 5 is 20. X, the x loses a power, becomes a 3, so the 4 becomes 3. Minus 2 times 20, which is minus 40x, and that's that. If we, by the way, if we wanted to factorize that, I guess we could factorize that. We could take 20x, do it like that. That's one way of simplifying it, I guess. Okay, so a function is defined by y equals x to the power of 6 minus 2x to the power of 4 plus x squared. Find the gradient where x equals 2. This is a precursor of what we're going to be doing in the next video. So first thing we need to do is differentiate it. So 6 comes out the front, we lose 1. 4 times negative 2 is negative 8, and the x loses a power. The 2 comes out the front, and it's just 2x. All right, now what do we do? To find the gradient where x equals 2, we just substitute wherever we have an x equals 2. So 6, 2 to the power of 5, minus 8, 2 cubed, plus 2 times 2. 2 to the power of 5 is, I think, 64, I think. 2 to the power of 5 is 32, sorry. So 32 times 6 is 192. And 2 cubed is 8, so 8 times 8 is 64, plus 4, so 192 minus 64 plus 4 equals 132. So in other words, this is some function, and where x equals 2, so x equals 2, it's going up at sort of a huge rate. For every one that it goes across, it goes up 132. So it's very, very, very steep. And that's all of them. That's quick fire, 10 questions, sort of just to bash away at doing differentiation of polynomials.